Pretty important topic for Year 12. A lot of your subtopics are going to be based off this topic. So exponentials now, logs and everything is actually based off this topic. So this is like the algebra of Year 12. The good news is it's actually not that hard. It's actually really, really straightforward. The concepts are pretty straightforward. But like I said, it's pretty important to master it. Now, this topic itself is worth about 15 marks in your HSC. 10 of those marks are pretty easy. So we're going to get those 10 marks. We're going to get those 10 marks out of the way today. The last 5 marks, which are band 6 questions, they take a little bit more time, and we might spend the next 3 to 4 weeks on those. Those band 6 style questions are at the end of your paper, so they're usually really hard. So on one exercise, I'm going to take 3 to 4 weeks on just one exercise. Whereas the whole chapter, the rest of the chapter, which is going to be today. So that one exercise that we'll do for the next few weeks, you understand that that's really hard. That's probably the stage that you've got to spend a lot of time at home to master, so that when your peers learn it, you're ahead of them, because they're not going to learn it as, hopefully, with enough time as you guys would have had. Cool. So today's lesson should be pretty easy. Things are not too hard. You just got to get the words correct. There's certain words that you just have to get them right. And that's what we're going to emphasize today. So let me do that by starting with this. So the first thing we're going to learn is increasing, decreasing, and stationary points. So a function is said to be increasing if the tangent has a positive gradient. So a positive gradient means slope to the right. So something's increasing if it's sloped to the right. Something is said to be decreasing if it is negative gradient or slope to the left. And something is said to be stationary if it has 0 gradient. So when you see the word, or when you hear the word stationary, we talk about the gradient or the line is flat. Does that make sense? In other words, this is what you really need to know. Y dash, which is your first derivative, if it's greater than 0, it is increasing. Y dash is less than 0, decreasing. Y dash equals to 0, stationary. Say it again. Y dash greater than 0, increasing. Y dash less than 0, decreasing. Y dash equals 0, stationary. Make sense? Any questions? Very important, but like I said, pretty straightforward. So on the following graphs, indicate where the function is increasing, decreasing, or stationary. Well, increasing, true, slope right. What's happening right there? Stationary point, or the word you guys were used to obviously was turning points. Turning points, stationary points, same. So that's y dash equals 0 technically there. Y dash is greater than 0 technically there, right? What about here? Negative, 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 negative until another stationary point. Y dash equals 0. This one, y dash less than 0. And you can see it's sloped to the left. And then I'm just going to continue this now. Positive, 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 positive. Make sense?
The turning point only before that stationary point if it changes from positive to negative, positive.
Correct.
So like the end of this one, there's a slight curve, but it wouldn't count as stationary.
That's going to be called a horizontal point of inflection, and you'll see that in a second. Yep, a good observation. There is a little bit of a curve there, and yeah, it's a point of inflection. So it's technically stationary, but I don't want to introduce that just yet. But good observation, like I said. Next one. Again, positive, 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 blah, blah, blah. I think you guys get the idea. Flat, these are all negatives. They slope to the left. Flat, positive, 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 flat, negative, 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 negative. Any questions? No? Easy. What you want to take out of that, it's not so much the positives and negatives, you're not really going to get tested on that. It's more y dash greater than 0, positive. Y dash equals 0, stationary. Y dash less than 0, negative. All right. Show that y equals 5x plus 7 is increasing for all values of x. What's the key word there? Increasing. What do we know about increasing?
Y dash.
You've got to be strict with yourself. Y dash greater than 0. Because we're going to have y, we're going to have y dash, and we're going to have y double dash. So yeah, y dash greater than 0. Good. And then that's it. Here we go. Y dash equals what? 5, which is always? Yeah. Therefore, it's always increasing. B. Larson and Hefty, just stop me if I'm going too fast. B. Show that y equals x cubed is increasing for all x values except or apart from x equals 0 where it is stationary. Well, let's see. What does y dash equal to? In this case, no. Y dash equal to 3x squared. 3x squared. Which we know is always what? Positive, except when x equals 0. Literally what the question is telling you. So, is greater than 0 for all x except at x equals 0, where y dash would equal to 0, right? 3 times 0, y dash would equal to 0, therefore stationary. So 3x squared is greater than 0 for all x except at where y dash equals to 0, which means therefore it's stationary. So for all x, that's it. Make sense? Because no matter what you sub in for x, like 1, 2, -1, -2, they'll always be greater than 0. They'll always be positive. Good. Pass. For what value of x is this increasing? Again, keyword is increasing. You realize that means, and do that. Like just like maybe back then we used to write our quadratic formulas out every single time. Same thing with these. You see these certain words, write it out. Y dash is greater than 0. F dash or y dash equals 3x squared minus 6x minus 9. That becomes a quadratic. Divide everything by, well, that, we want that to be greater than 0. So we're going to solve this. If you guys have been doing it my way, we make it equal to 0, usually, right? And because I can see there's a common 3, I'm going to divide that out straight away. So at least it's easier for all of us to see. There it is. Factorize. X equals 3 and x equals -1. What do we usually do after all that? Draw a, remember we want an inequality. We draw a number line, then there's -1, then there's 3, and then we usually test. Good work. We're going to test x equals 0, so right in the middle. Where do we sub it into? Obviously y dash, because that's what you want greater than 0. 0, take away 0, take away 9 is -9, bigger than 0. I don't think so. So then that fails, which means they are running away. And what's the final answer we have to write? X is smaller than -1, comma, x is bigger than 3. Rings a bell? Nothing too hard, right? Once it comes back to you, it shouldn't be that difficult. Next one's pretty repetitive, so I'm going to leave that one for homework. And we'll check it, or classwork soon enough. We'll leave example 3 and we'll move on, because you guys are killing it. This one we'll do at the end, so I'll come back to that in a sec as well. But let's start with stationary points. All right. This is going to be worth 2 marks in your exam, just the stationary point bit itself. To find a stationary point, let the gradient function, which means y dash, equal to 0, which we already know because we just spoke about that, right? We said, when is it stationary? When y dash equals 0. So, find the stationary points of the following functions. Y equals x cubed minus 3x squared. What's my first step? Differentiate. Y dash equals 0. Derive. Y dash equals 3x squared minus 6x. That needs to eventually equal to 0. And then you just solve, however you've been solving. So to me, I'm going to factorize 3x out. And then I get x equals 0 and x equals 2. Any questions from that one? No? Pretty happy with it? All right. What's the key word in stationary points? You would think so.
Points.
What's so special about it being a point?
Because there's two.
What do you mean by that?
It's points.
Right. Plural, I get that. It could have been stationary point, but what's so special about the word point itself compared to what I've just done? Yeah, that's okay, but again, don't have so much that. Think of point itself. What does a point need to have? Bingo. What do I only have? X. I've only got X. It says it's a point. So what am I going to do? Sub. If they make it too hard, get back to your basics. So sub it back in. Sub back into the original, right? X equals 0. Sub back into the original. You're going to get 0. Sub back into the original. 8, take away 4, 3, 12, negative 4. Done. So what are your two stationary points? 0, 0, and 2, and negative 4. It's a point. That's what I'm trying to say. So when you do y dash equals 0, that only allows you to find x. You need to be able to find y as well. But that's easy, just sub back in. Done. You guys want to try B and maybe even C? Y dash equals 0. All right, my turn. Let's see how we went. Find stationary points. Y dash equals 0 essentially, right? So y dash equals 4x cubed minus 16x. Eventually will equal to 0. When I see this, I can factorize a 4 and an x out. X squared minus 4. What do you get for your x values? No, 0 is correct. 2 was right. It's not fully right. Because yeah, it's the difference of two squares, which becomes plus minus 2. X equals 0, x equals 2, x equals negative 2. Yeah? And then again, what are you going to do at this step? Sub back in to your y value. Very important, because there's going to be a few things we're going to sub back in. To your y. Not y dash, and not y double dash. It says y. So sub it into y, I get 0, sub it into y. 16 take away 32, I think negative 16. Is that right? I think he's checking for us. Next one, y equals x cubed, pretty easy. Again, y dash equals 3x squared. When e equals to 0, you get x equals 0, and obviously y equals 0. Any questions? The one you're looking at it.
What was last for the,
For B, go back up.
why is it equal to 25?
Maybe I did it wrong in my head. Okay. Thank you. 48.
Oh,
No.
Negative 6 times for 2 and negative, or negative 12 and 48.
No, they have to be the same answer. Wait, yeah, they have to be the same answer. I can just see it. 2 to the power of 4 minus 8 times 4 is negative 16. Is that what you guys got? That's what I had at the beginning.
Yeah, but we did negative 2.
Use brackets.
Oh, not on the, not the first.
You must have also not used brackets. You must have just gone negative 2 to the power of 4. Let me see. Minus.
Yeah, I think.
Yeah, see, now I've got your answer. Here's what you wrote.
Yeah.
Yeah, no good.
Yeah.
Because that negative is still going to be there. Okay. Always use brackets. More brackets is better than less brackets. You're in year 12 now. All you should be using is brackets. All right, move on. Okay, the question now arises. What type of stationary points do we have? There's actually a few different types. We've got a maximum turning point or stationary point. We've got a minimum stationary point, the ones you guys are aware of. And then we've got the one I think Giovanni was saying before. We've got these ones here. These squiggly ones that are coming from cubics. They're actually called horizontal points of inflections. Why? Because they're horizontal and they're points of inflections. We'll talk about points of inflections soon. So, again, I think I'm going to leave this bit because I think it's just a bit easier. Oh, that's right, I might do it with you guys. Consider the gradient of the tangents on either side of D and B to complete this table. Okay, on D, just by looking at it firstly, what kind of turning point is that? Is that a minimum turning point or a maximum turning point? That's a minimum, right? So D, just before D would have been, it would have been any point, right? It doesn't matter what point that was. So just before D, pick any value just before D. What is the first derivative? Well, isn't that slope to the left? So wouldn't it have been a negative number? Right? Because y dash is less than 0 if it's decreasing. What happens at D? First derivative is always 0. What happens just after D? It's always increasing now, which means it's got to be positive. And what kind of stationary point is this? When it's negative, 0, positive? Yeah, but no, what kind of stationary point is it? It's a minimum stationary point, or a minimum turning point. So it's a minimum. What about at B? At B, it is increasing here. So what's happening at just before B? Just before B. It is increasing, so positive. What's happening at B? 0. What's happening at after B? It's also positive. So what kind of stationary point is this? Horizontal point of inflection, specifically. Point of inflection. You said it right, but you're going to realize the difference between the two. When it does that squiggly, it's a point of inflection. Actually, let's talk about it now, since you're already here. You see E? E is a point of inflection. Why is that a point of inflection? What is a point of inflection? A point of inflection is just where it changes from happy to sad. So have a look, or sad to happy, whatever. So have a look. Happy, 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 happy. Something needed to happen here for this to change and become sad. Can you see that happening? That point where it changes concavity is called a point of inflection. If it's like this, a horizontal one, it's called a horizontal point of inflection. So that one there, from a happy to sad, is called a point of inflection. These squiggly ones are called horizontal points of inflection. But we're going to get onto that anyway, so we've got a lot of work to do with that still. Okay, so now we've got 2 marks from stationary points. Let's get the next 2 marks for nature. And then the last 2 marks will be sketching this. So right now, that question itself is worth 6 marks in your exams. But they're pretty easy.
What's the minimum?
Nature means minimal or maximum, or point of inflection. So let's start. Step 1. Stat points, you underline it. Why? Because it just looks neater, and we get to read your work instead of just all this math. Y dash equals 0, so that you don't forget it. It'll just be engraved. Stat points, y dash equals 0. Let's do it. Y dash equals 3x squared minus 3. Eventually this will equal to 0. Can anyone see what the values of x should be when you solve for this? No? Can't see what it should be? No. You're going to plus the 3, then you're going to divide by 3, and you're going to square root it. X equals to 1 and minus 1. Right? I hope you guys would have done that. Or you could have factorized the 3 out, realized there's a difference of 2 squares. Same thing. Alright, what do I do now? Once I've got that, find my y. How do I find y? Sub 1 into the original. 1 take away 3. Negative 1 plus 3. Done. 2 marks. Finished. There's 2 methods for doing nature. We're just going to do method 1 right now. And as we work throughout this lesson, we'll look at method 2. Method 2 is easier than method 1, but method 2 won't work all the time. So you need method 1 as well. So you need to know both. Nature. The way we do our nature is what we literally just did above with that table. We're going to create a y dash table. So nature, y dash table. So what are the points we've got? At 1 and negative 2, at 1 and negative 2, here's our y dash table. X, y dash. True. And then at -1 and 2, here's another y dash table. I'll just pause there for a second. Does anyone have any questions at all? No? Giovanni, okay? And what are we trying to obtain from the y dash table, essentially? What did we find before? Yeah, you want to find its minimum, maximum, or quantum inflection, whatever. That's the whole point of this y dash table, because it gives us the gradients, right? Okay, the number in the middle has to be the x value you've chosen. It's an x, right? X, 1, 1. What does y dash equal to? What's the first derivative, or what does y dash equal to when it's x is 1? What does y dash equal to? Not -2, that's y. Y dash equals to 0 when x is 1. True? Isn't that what you just did above? Right here? So that middle term, you can memorize it. It's always got to be 0. Let's go above, just so you guys can see what we're doing. Look, you found it's already a stationary point. So what does the middle always become? 0. Just has to. Good. Then we choose a number before it, and we choose a number after it. And then what are you going to do? Sub into y dash. It's very important. We said before we said sub as well. We subbed it into y. Now, because it's a y dash table, we're going to sub it into y dash. So 0 into here is -3. 2 into here, 2 squared is 4. 4 times 3 is 12. 12 take away 3, 9. Same thing with this guy. I can see it. So there we go. Any questions so far? We're literally there. All we're going to do now to work out its nature is recall, what did we say y dash is when it's less than 0? Y dash less than 0, decreasing. Decreasing. Slope to the left. Can you see that? Then what happens when y dash equals 0? Horizontal, flat, stationary. Yep. And then y dash was greater than 0. And what kind of thing is that? What graph is that? It's a minimum one. So now you know it's a minimum turning point at 1 and -2. The numbers are not important, as you realized. So it doesn't matter if it's 3, 30, 50, 20, -50, -100. It's all about negative or positive. All right, this one. This is positive. How do we slope a positive? Slope to the right, 0, slope to the left. And again, by you drawing that, can you see what it is? It's a max. Done, finished. We're happy? Any questions? Let me go back, and I think we just got to sketch, don't we? Sketch. One and -2. X is 1, -2, right there. X is -1, y is 2, right there. And you can see it kind of makes sense. You see how that's a maximum turning point? And that's a minimum turning point? Oops. I should have really cut it at 0 because I can see when x is 0, y equals 0. But I missed it. Well, there you go. Done. 6 marks. That's a lot. For something that will get very, very repetitive very quickly.
What's the next one?
100. So if you want to think about it, this topic is going to get you 10% already. there's a few HSC questions in here that we've taken out, and you can see them. But like I said, this one, most kids get it out. So you can assume most of your students in your class are going to get it out. It's the next bit, those maximum problems, less than 1% will get it out. Less than 1%. So that's the one you want to focus on. This one, once you get it, yeah, everyone gets it. So it's okay. Go. There's nothing for me to do anymore. You try it. I'll give you guys, 5 minutes. Again, what are you trying to do? Stationary points first. Y dash equals 0. Sub it back in. Do your nature. Take your time. I'll leave it with you guys. That's it. Sam, any questions? No? Is it attached or not? Yeah, is this here attached to everything or just the other? It's just attached to one. Yes. Attached to one. So what you're left with is 1 in the scale, and about 3.
So it's just like nothing.
Yeah. And then the 9 over 3 can simplify. Yeah. So then it becomes technically 3 over square root of it. Yeah. So it's 2 steps like that. So I'm going to kind of like cube. 1 cube. Yeah. 125 x6 minus x, or x minus x equals x7. So first expand that one, then multiply, which means you can add the bases, add the indices, and then because you have an x7 on top and an x7 on the bottom, you're going to cancel out. Expanding 125 over 25 is plus enough. Yeah. Thank you. See you. All right, how do we go? You've done something wrong. Probably more the algebra, right? I don't think it's the topic. The topic is easy. It's the algebra bit, the quadratic and stuff, I'm assuming. So let's see. That's just what I've realized over the years. Y dash, stat points. Y dash equals 0. So we're going to do what? 15 x to the power of 4 minus 60 x squared equals 0. What do you do at this stage? Factorize what out? Find x squared. Yeah, 5x squared is fine as well. It doesn't matter. It's more about the x squared. That's probably the biggest thing. 15, because it's an equation, it will eventually be divided out anyways. Doesn't really matter. But yeah, x squared. So 15, x squared is actually the highest one. You're left with x squared take away 4. Then you're going to have x equals 0 for this one. And you're going to have x equals what for this one? You said that again. Yeah, plus minus. Stop missing it. X equals 2 and negative 2. This topic will make you never forget it again. X equals 2 and negative 2. And then sub it back in. Y equals, oh, I think I just realized why you think you've done something wrong. Is it your nature? Or no?
No, factorize. I didn't do x squared and brackets x2 minus 4 x squared minus 4.
But you still factorize x squared out?
Yeah.
Ah, okay. Y equals 0. Y equals negative 16. We'll accept it if no one says otherwise. And same thing. Shouldn't be. Maybe positive 16. For both of them? Let's check. All we're doing is substituting. 3 to the power 5 minus 22 cubed negative 64. And then this one should be, I'm guessing, positive 64. Yep. So what mistake did you make there? Ah. No. Nature. Okay, nature. We're going to do our y dash table. So at 0, 0. At 2 and negative 64. At negative 2 and 64. True? You happy with everything I've written there? Because that should be your first thing regardless. Nikki, all good? Then we choose one number before, one number after, one number before, one number before, one number. And where do we sub all these numbers in? Into y dash, into this guy here. All right, let's see. Negative 1, I can see you get negative 45. At 1, you still get negative 45. At 1, you would get negative 45 because we just did that. At 3, $675. Yeah. Like I said, the number's not that important. It's more the sign. Okay. And finish it off. Let's start with these guys. Slope to the what? Left or right for the second one? Slope to the left, then 0, then to the right, up, which is a mean. Look at it, think about it. Think, Aiden, look, let's just start up here, and you're going down to get the minimum value, then you come back up, min. What about this one? Slope to the right, 0, slope to the left, which is a max. And then we've just got this first one here, which is a negative, 0, and then again a negative. What was this one called again? Horizontal point of inflection. Good work. You guys are doing well. The only mistakes I'm seeing is the algebra bit still, that factorizing stuff. Done? Let me know if you've got any questions. No? All good? It's literally what I'm saying, right? It's just the beginning that you guys are stuffing up.
Yeah.
Is it? The rest is okay? Substituting, is it? Or not? I don't know. I need to know.
I kind of confused myself with this part.
Yeah, tell me like what bit so I can...
Just the nature part.
Is it the fact that you're substituting it in? Is it this, the orange bit?
Oh, no, I get that.
Yep.
It's just like, oh, it's just me. Like, I confused myself with like what you wrote in.
Sure. Okay, fine. All
And
right.
also like the stat points, just the algebra.
Yeah, done. Okay, next section, second derivative. I think you guys understand what second derivative means. Oh, did it say sketch? Thank you. So there's 2 and negative 64, right there. And then there's negative 2 and positive 64, which is right there. And then at 0, 0 is a horizontal point of inflection. Can you see that's a max? And that's a min. Yes? What did we do with the question above? So what did we do here? We just met, they just met together in the middle, right? At 0, 0. This one's saying, no, don't meet at 0, 0. It's a, like this, horizontal. It's a squiggly, if you're used to that by now. So ready? Watch. Very similar, squiggly. Make sense? Seriously? Yeah? Oh. All right. All right, next one. Second derivative. I think, like I said, you know what you've got to do. You just differentiate twice. So y dash equals 12x cubed minus 6x squared plus 3. Y double dash equals 36x squared minus 12x. Easy? All right. Now there's a way to do minimums and maximums without the y dash table. It's called the y double dash method or technique. And here it is. The second derivative can be quite useful in helping us determine the nature of a stationary point as well. If we know that y double dash is greater than 0, it is a minimum. If y double dash is less than 0, it is a maximum. If y double dash equals to 0, when you're trying to do nature, it is inconclusive. And we're just going to say it's a possible point of inflection. Point of inflection. Those are the words we use at that stage of nature. This is where it gets confusing, because everyone starts mixing up their increasing words with their minimums and maximums. So let's say it again. When is something increasing? When y dash only, correct, greater than 0. When is something a minimum? When y double dash is greater than 0. How are you going to remember it? I guess the way I remember it is greater than 0. I usually think it's going to get bigger. So I would think it's maximum, but I've integrated in my mind, it's the opposite. So it's not a maximum, it's a minimum. That's just all I could do. So that means less than 0, my brain would usually think that's a minimum, but it's not a minimum, it's a maximum. Does that make sense? So I do it as opposites. So whatever I think logically is incorrect. I was just trying to say, please make sure to not mix up decreasing, increasing with maximums. All right. Here we go. Example 8. Find all stationary points and then determine their nature using the second derivative. So let's try this. So this is nature, done the second method though. Do y dash. 3, take away, 3x squared. Again, equals to 0. Again, can you guys tell what x should equal to? Think about the solving it. Eventually, x equals to... No? Got nothing for it? I can see I can factorize a 3, otherwise if not, look, divide by 3, square root plus minus 1. You could have done that, you could have even done this, difference of 2 squares. We would have still got x equals 1 and x equals negative 1. Whatever. So x equals 1 and x equals negative 1. What do we do now? Now that you found x, subbing in, find y. 3 take away 1 is 2. Minus 3 plus 1, minus 2. Something like that. Use your calculators, yeah. Like you do not want to make any mistakes for this like that. But anyways, that's done for stationary points. Oops, I forgot to write stat points. Otherwise, it just looks like a whole bunch of everything. You don't know where to start. Nature. We are not doing the y dash table. We're doing it through y double dash this time, which is actually really nice. Because y double dash is what? Negative 6x. Y double dash equals negative 6x. Yep. Then we just do the same thing we did before, which is at 1 and 2, and at negative 1, negative 2. All right, what does y double dash equal to when it's at 1 and 2? Negative 6x, but what does x equal to? 1. So negative 6 times 1, which is negative 6, and negative 6 is less than 0, therefore it is a maximum. You can't say that's y dash. So I said you don't want to mix the two up. This is a second derivative. This one's a maximum. Straight away. There's no need to substitute things in. Makes it a little bit easier. Y double dash equals negative 6, negative 1, which equals to positive 6. That's greater than 0. What do we know about y double dash greater than 0? Min. You're done. If you're ready, start the next one. Stationary points and nature using y double dash. I'm just going to walk up. before I forget, next week I can't be here because I am a groomsman at a wedding with my best friend. So I won't be here. Join the Thursday class or come in on Thursday. What time? 6 to 8. Join that one. So if you can't make it at 4 to 6 on Thursday, come to 6 to 8 because we're all doing advanced. Differentiation, everybody's doing advanced. I can't do Saturday. If you want to join, I'll be sending the link anyways to the Skype page. You can join online. Don't miss it because we're going to do the max min problems, the things that I said that's hard. And if you can come here, come 6 to 8 or 4 to 6. You're already here, so just stay back 6 to 8. So yours is easy, 3 of you. And like I said, Larson, you're here as well, so you're going to stay back, you're easy. Hetli, up to you what you want to do. I'll send the link. If you want to stay online, you can. Same as you three. 6 to 8 or 4 to 6. Or 5 to 7, it doesn't matter. That whole 4 hours, we're all going to be doing the same thing. So it doesn't really matter when you come. Make sense? But then after that, we're back to Saturdays. All right, let's go. Example 9. If f of x, find any turning points and their nature. All right, here we go. F dash or y dash equals 0 for stat points. 4x cubed equals 0. Therefore, we only get x equals 0. Y equals, sub in 0, you get negative 2. Then we do nature. What are we doing for nature? Nature is y double dash, which equals to 12x squared. And we write at 0, negative 2. What does y double dash become? 12x squared, yeah, but at this point. That's why I'm writing it like this, at here. That means sub in x is 0. So at this, x. Does that make sense? Y double dash, it's got an x, but x is 0 now. What does it become? So that's not greater than 0, so we can't say it's a minimum. It's not less than 0, we can't say it's a maximum. The only conclusion you can make at this stage is possible point of inflection. Possible point of inflection, that's it. You can't even say it's a point of inflection until we do the third part, which is coming. Cool?
How come it's possibly sometimes it is, sometimes
Yeah, that is exactly right. What you just said. Sometimes it is and sometimes it isn't.
it isn't? Is there a reason?
Because there's so many graphs in the world, right? And so many things that could happen. Like there are graphs that you guys are doing graphs this way, but there are graphs this way, sideways, and like things change already. So, and there's just it's endless. It's not flawless. You're in year 12, right? This is like the first 10 minutes of the first day of university. First 10 minutes. That's it, that's all you've done, move on. There's nothing. So it's so basic that, yeah, I'll let you go again. But I don't know. It's not flawless. That's all I can say. But that's why you got to say possible point of inflection. But it's a good technique. It's good. Okay. Determine the points of inflections. I think we already spoke about that. The point of inflection would be right there. That's a point of inflection, right? Because it changes from sad to happy. And wait, and there's another one right there somewhere, isn't there? From happy to sad. Is there any more? Yeah, maybe add the green, but I think it's actually somewhere more here. Right? Because see, that's sad, 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 sad. And then what happened right there? Changes to a happy. And what's that one called specifically? Not just the point of inflection, it's called that one's horizontal. Right? So these ones that are normal, point of inflections. These ones that are more flat, they're horizontal. point of inflection. The POI, HSC, it's allowed. Some school teachers don't like it because it means, they think it means like point of intersection or whatever. Fair enough. Like talk to your teacher, whatever your teacher wants, just do it. The POI in the HSC, we're a little bit smarter, we understand what it means. To find an inflection point, let y double dash equal to 0. That's it. So how do I find an inflection point? You make y double dash equal to 0 and you solve. The problem is, it is not an inflection point by just solving. So you know how in stationary points, we just went and solved and that's it, it was done. We said it's a stationary point. For points of inflections, it's not enough to just solve. You have to actually prove it. Now, every single year, I've had one student that's got that wrong in their exam. Why? Because the question was worth 1 mark and it said find points of inflection. So they went and just did y double dash equal to 0 and they stopped. Unfortunately, because you didn't prove it, it's a 0. Doesn't matter if it's worth 1 mark. Stationary points, even if it was worth 1 mark, you stop. If it's worth 2 marks, you stop, it's fine. You're done. So you'll see what I mean by proving in a second. It's just something I need you to remember, maybe write it down. With points of inflections, you must always prove. And you're going to see me write that in a sec as well. All right, show that 0, 0 is an inflection point. So let's go find it. How do we find inflection points? Y double dash this time. So POI, point of inflection, underline, y double dash equals 0. So this is, as you guys can see on the board, that's literally everything you're going to be doing, every question. The HSC will break it up, I, double I, but you don't need to break it up because you already know it's going to be there. So it's going to be I, double I, triple I, and IV is going to be sketch. So what you want to memorize is just this whole thing. You don't isolate things. You don't even know read the question. All you're going to read is the equation. And that's how you spit it all out. 10 marks. So start points, y dash. Nature will probably do the y double dash technique. I think it's just a bit easier. And then y double dash equals 0. For point of inflection. So let's see. Y dash equals 3 minus 3x squared. Y double dash equals negative 6x. When this equals 0, x equals what? When you solve for this, what equals to 0? What does x equal to, so? 0, sub back into the original, you're going to get y equals to 0. Show that 0, 0 is an inflection point. Everyone usually goes, done. I proved it. No. No, no, no. It's a trick. Don't do that. You've got to actually prove it like this now. So you're done. So to prove, I'll write must prove. Back in stationary points, we use what was called a y dash table. What do you think I'm going to call it now? I'm trying to make it easy for you. Y double dash table. By the way, where we are up to right now at school, this will take about 3 weeks. Right? The stage we're up to, it's about 3 weeks of lessons. We've done in about an hour. With a lot of practice, you guys are going to get there as well. But it's because I'd rather spend those 3 weeks on those hard ones, maximum problems. Okay, back to this. 0, you know y double dash is equal to 0 because you just solved for it. Choose a number before, choose a number after. Sounds good so far? Where am I going to sub in negative 1? Y double dash, because that's what it says here, y double dash. So it must prove y double dash table. All right, cool. Negative 1, sub it in here. That gives me a positive, sorry, sub it into here, y double dash. That gives me positive 6. Positive 6. Sub in 1 gives me negative 6. Let's recap. What did it mean when y double dash was positive? Minimum. What did it mean when y double dash was negative? Maximum. So what the heck happened in between them? No, an actual point of inflection now. Because you just proved that before it there was a minimum and then it became a maximum, that means somewhere in the middle must have been a point of inflection. And that's what we mean by proving it. So now the statement you're just going to write is since change in concavity, so that means concaving up, concaving down. So since change in concavity, 0, 0 is a point of inflection. Easy? All you gotta remember is the y double dash table now. And that statement, since changing concavity, 0, 0 is a point of inflection. There's nothing else we're going to learn for today. That is it. So we're just going to keep doing these over and over again. Find all critical points. So let's find our start from the beginning. Start with stat points. Y dash equals 0. Go and find the nature for that. And then do the point of inflection, which is y double dash equals 0. So I'm just going to leave it with you guys again. We'll do it.
Please don't be like this person. I just emailed me saying she wants children. HSC exams on 26 of October. It's next week. And no matter what I do, you'll never improve. Alright, don't do that. Don't get to that stage of your life where you only realize a week before your exam you need tutoring. Like, come on. Wow. No?
Would you like R&D institutional style?
Never. Never. Because those guys by now we're already done. Like you guys will be done by end of term 2 next year. Done. All we're going to do in term 3 is papers over and over and over and over and over and over again. For the trial HSC and the free HSC. And it's done. Over the holidays, no one usually sees me. I haven't had maybe 2 U12 students of mine this year. That's it. Oh, the rest is ready. No. No way. And plus, standard. So I know. They just left it last minute. All right. You don't need to look back. Tell me what you're thinking. I'll help you. Tell me, because it might confuse you if you look back. So you've done your y dash?
Yeah.
So what did you get? Y dash equals
So what did you get for y dash?
Something wrong.
Tell me what you got for y dash.
Oh, y dash,
Yeah.
3 squared plus 4x plus 9.
Correct. Plus 9 equals 0. And that looks like a quadratic formula. If you wanted to. If you didn't, if you wanted to factorize, we could factorize by dividing by 3. Because why not? Makes it a bit easier. And then you can factorize. But if you feel like you can't factorize, or you're not getting them right, then get rid of it. Me, I pretty much by second term of year 11, I decided because I was going to, because I was doing such high level math, I got rid of factorizing. All I knew was quadratic formula, but I could do it in 2 steps. So I perfected my quadratic formula so that it wasn't as slow as it usually would be. It became as fast as someone's going to divide by 3 and factorize and whatever. You know what I mean? So just jump into quadratic formula. It's fine. X equals, essentially it's better to get it right and do it longer than it is to not. Yeah, so just forget factorizing. How about that? You won't need it. Because everything you're going to do in year 12 is solving. So quadratic. You see it? Quadratic, just solve it. All right, -3, sub back in. The rest of us, how are we finding this? Okay, at this stage? 0, 0, y equals 0, and then -1. I got -4. Yep. Nature, what are we going to do? The y dash table or y double dash? What are we liking now? Y double dash, let's do it. So we're going to do the y double dash method. I'll just call it here. All right, so we write at, because you've got to tell me where you're at, otherwise I'm going to get confused. Y double dash at -3, 0. What does y double dash equal to? Well, y double dash is 6x plus 12. Right? 6x plus 12. And then what are you going to do at this stage? That's great, but you want to at this point, which means it equals sub in x, which is -6. What does that mean? If y double dash is a negative, at x plus 12. -6 plus 12 is 6, greater than 0, min. Now do y double dash equals 0 and see if you can prove it as well.
The gradient of this will be the same as gradient. Good. Can you put the gradient of the one, you start with 1 minus 1 equals 1 minus 1. Okay. You sure? You really have a point. Yeah. What's the main reason? What other point am I talking about? 1 minus 1.
All right, point of inflection. Hopefully we got it now. What did you get, Nikki? X equals? Minus 2, because 6x plus 12, when you make it equal to 0, should be negative 12 divided by 6 is negative 2. Then you sub it back into the original, because you want to find the y value, right, the point. So back into the original, negative 2 cubed plus 6, negative 2 squared plus 9, negative 2 is negative 2. But you can't just say that's a point of inflection. Now we have to do the y double dash table and prove it. So we've got to prove it. That's what you've got to remember with points of inflections. Anyone started this topic at school yet? Class still in year 11.
Yeah.
Oh, behind. Well, I'm hearing some schools are still doing it up to at least week 4. Oh yeah, that's year 12. Yep. We'll be doing graphing techniques, I think, next year. Then we'll be doing finance after this. But good news, graphing techniques are actually the same as your other. That's the good news. There's actually nothing new. You're just going to be going x squared plus 5. You've got to shift your parabola up 5. X squared minus 5. You just repeat. That's the good news. But I'll give you work on that. If we get time to finish, why not? Graphing technique is our third topic. Negative 2, y double dash equals 0. Choose a number before it. Choose a number after it. Sub it in. Negative 18 plus 12, negative 6, and 6. And then what do we say? Since change in concavity, what? Negative 2 is a point of inflection. All right, you guys. Larson, any questions? Am I going too fast? Is that him? Oh, all right, sounds good. Yes,
For example, the y dash table.
y dash table, yep.
For example, if there's like, under maybe 1 x y, if it's contained, do that like
Y dash table or y double dash table? Oh. So this one here,
Yeah,
if it gave me, instead of the negative 6, it gave me an 8.
yeah.
No. If it gave you that, there's no change in concavity. So therefore, bingo. That's why you got to prove, like, so what, you just did some math and you made something equal to 0 and you found this, right? That's great. But it doesn't mean it's a point of inflection, because if this failed, that means it's not a point of inflection. You just did some math. You just made y double, you just went and did y double dash. Like, if you want, you can do triple dash. So what? Right? You're just doing stuff. I just said I'll make it equal to 0 again. So what? But the way you got to prove it is there has to be a change. The order doesn't matter. Like your y dash table, that one did matter because like it changes from a minimum or a maximum. The order doesn't matter. There's just got to be a change. The numbers also don't matter. Doesn't matter if this is negative 50 and then 6. But if they don't change numbers or signs, since there's no change in signs, you would have to say it's not a point of inflection. Because then that means it's a maximum, then a 0, then a maximum again, which is weird. Really weird.
What would a horizontal point of inflection look like in the table?
Good. A horizontal point of inflection would still be a point of inflection. True?
Yeah.
So on the table, it'll still look the same. But that would make a difference. How do you know it's a horizontal point of inflection? Well, doesn't horizontal mean it had to actually already be a what point as well? A stationary point? Because a horizontal point of inflection is actually going to be at y dash. So you would have found it here, and you would have found the same point here. Does that make sense?
Yeah.
That's why in nature, what would you have got here? It would have said possible point of inflection. Then you would have come up here, you would have proved it's a point of inflection, and then you would have said it's a horizontal point of inflection. So the ones that you're going to get possible, they're the ones that are going to probably be horizontal points of inflections. Otherwise, everything else is just a point of inflection. It's coming up. I think it's this one. You'll see it. Go again. Don't just do points of inflections. Let's just do everything. So start from the beginning. Stat points, nature. Wait, can you do stationary points? I think so. Stationary points, nature, and points of inflection. So do the whole thing. I'll give you a layout for those who are at home as well. I think this is what you want to essentially do. This is your y. This is your y dash. This is your y dash. This is how it should always look. Then the next line would be stat points. Then eventually you're going to find nature. And then eventually you're going to find point of inflection. And that's it. If you can pretty much memorize those steps, that's worth 2, 4, 6 without the sketch. And then the sketch will be the 8th mark. All right, I'll leave it with you guys again for a little while.
Yeah, one more question.
All right. My turn. I don't think you need to refer back. What do you think? I think, but the problem is the numbers are very different and stuff. So when you're checking, you might get yourself confused. That's what I'm saying. You might not need to. So you walk me through. Go. Y dash. What'd you get?
5x to the power of 4 minus 20x.
Then y double dash, since we're here.
20x to the power of 60x.
Done. For stat points, we make the y dash equal to 0. So what would you have done? when you have this thing equal to 0?
Take 5 out.
Just 5?
5x.
Beautiful. I like it. That's better. 5x cubed. Bracket x minus 4. You agree? Equals 0. So therefore x equals what and what?
That's right.
Okay. Right, ready? Remember when we had two brackets and something had to equal to 0, we made each bracket equal to 0? Wasn't that the logic for solving quadratics? So we said x plus 2 is 0 and x minus 3 is 0. So therefore you get x is negative 2 and x is positive 3. Remember that? What if it was x plus 2? Then we just go x is 0 for this one because there's nothing else attached to it. And x equals what for this one?
X plus 2.
But no, it is plus 2. So when we're solving, we're going to bring it to the other side. We're doing the opposite, which is minus 2, because it's going to become 0. Remember it was opposites, always? So in this case, therefore x equals, because there's nothing else that it's attached to, there's no adding or subtracting, x would equal to what for this one? Yeah, in other words, you're doing this, just so you know, 5x cubed equals 0. 0 divided by 5 is? Cube root of 0 is? That's why we're ignoring it. And then, what's your next answer? X equals?
Is it negative 2 and plus 2?
No, that's only if it was squared. It's not squared.
So it's just column.
X equals 4. Review today's work again and it'll stick. Done. Okay, that's easy. Easy place to fix. If it was x squared and you still didn't realize there was a difference of two squares or whatever, quadratic formula. So if it's squared, you can just do quadratic formula. That's a fail-safe technique for you. Okay? I'd rather you not get it wrong, but yeah, you need to know that if two things or three brackets or four brackets, then you just make each bracket equal to 0. Like I did here. Each bracket equal to 0. But I think by now you shouldn't need to make it equal to 0. You should just go x plus 2 means minus 2. Minus 3 means positive 3. All right. Good. All right, we got 0 and 4, and then we're going to sub it back in to get y's. Can someone tell me the answer to those? Y equals, for the first one, 0, 2, 5, 6. Confirm? Confirmed. Nature. Again, I'm guessing you guys did the y double dash technique. Okay. Nature. So at 0, 0, what does y double dash become? Yeah, but then at this point, what should it become? 0 cubed. Like this. True? So then it becomes 0, which means you would write possible point of inflection. Possible point of. Why can you only say possible at this stage? Because a point of inflection is your next step. So at this stage, all you can say is possible. And then again, at 4 and negative 256, what does y double dash become? 20, and you sub it back in. 4 cubed minus 60, 4 squared, which equals 320. 320, which is greater than 0, which is a min. Y double dash equal to 0. Now you got to make the y double dash equal to 0 and solve.
She said she's nearly done shopping, so send out
All right, y double dash. Go on, grab it. Y double dash equals 0. Okay, Nikki, what are you going to factorize out? 20x squared. 20x squared. X says eventually you get back into it again. You had a nice long holiday, you forget things. Equals 0. Now, what does x equal to? And? Good. X equals 0, x equals 3. Sub it back into where? Y. Yeah, you're right. No, why? Because we want y. Eventually we want y double dash. Right, but that will be called the y double dash table. Now you want x and a y. So yeah, right on the original. So 0, 0. And at 3, has anyone done it at 3? No, the original of the question, yeah. Why? Because you want to find the y coordinate, don't you? Not y dash coordinate. So 3 to the 5.
Negative.
Negative.
1.
Do we trust you? Usually I do. You're having some issues, substituting some things out. Let's have a quick look. Yeah, you're right. We trust you. Your reputation's really good. All right. Like I said, you can't stop. But just, I want you to realize what happened with something before we continue. I want you to look at stationary point. What did you find? You found x is 0 and y is 0, obviously. But look at what happened again at point of inflection. You found it also here at 0, 0. So if we prove that it is a point of inflection, you see how we said it's a possible point of inflection? It actually becomes a horizontal point of inflection. And the only reason why it's horizontal is because it's both stationary, yes, and a point of inflection at the same values.
Would we need to write up?
Yeah, at the end, correct. Cool. All right, let's do this table. Where's my? There it is. X, y double dash. Obviously, where do you sub back into? Not y, into y double dash now. X, y double dash, y double dash. All right. All right. I think it's one way, right? So that's 0. We choose 1 before, 1 after. We know that's 0. That's 3. Choose 1 before, choose 1 after. And that's 0. Go and sub it in. And let's see what happens. Into y double dash. Right? Y double dash was 20x cubed minus 60x squared. 20x cubed minus 60x squared. Okay, what did we get for y double dash at -1? I think so, I can see that as well. Yep, -80 and 20 take away 60. -40. Not a horizontal point of inflection. Can continue. Next one. -80 and 320. Okay, so this one, so since I'm just going to shorten it, change in concavity, if that's okay with everyone. CIC, change in concavity. Since change in concavity, 3 and -162 is a point of inflection. Since no change in concavity for this one, 0, 0 is not a point of inflection. So what is it? So that's when you got to go back up. Since no change in concavity, 0, 0 is not a point of inflection. We go back up, go up, go up, go up, go up, go up, up. Come back to nature, and instead of doing nature this way, what do we have to do? Y dash table. Y dash table. Absolutely correct. Bang, 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 bang. X. Y dash table. There's your 0. There's 1 before it. There's 1 after. Y dash. Sub in -1 into Y dash. I can see it becoming 5 plus 20, which is 25. Sub in 1 is 5 minus 20, -15. What is it? What is it when it's 25? 0, -15. Okay, 25. Slope to the slope which way? Y dash. If it's greater than 0, slope to the right. Then 0, then slope to the left. It's a max. Sorry? No, no, no. It's not a point. It's a stationary point, actually. You see here, we said it's a possible point of inflection. Then we realized when we came up to it, there was no change in concavity. So it's not a point of inflection, which means it must have been a turning point. So we went up and we realized it's actually a maximum turning point. No. Wait, what's a stationary point? The highest or lowest that you can come. Right? Where it's 0. What's a point of inflection? When it changes from a happy to a sad. Yeah. 2 different points.
How do you know when it changed?
Where it changed?
How do you know when it changed? Like in one of it changed in yellow.
Just the signs. The signs. So that there's no change. There's a negative and a negative. Which means it's a maximum and a maximum. Which now we know is a maximum. But this one, there's a maximum and then a minimum. Which means what? In between there had to be a? Exactly. Yeah, right. Today's only the first day, right? It's all good. All right. Let's go again. We're done. Print. Just another lucky day then. Yeah, let me look. For what values of x is a concave up? What does concave up mean? Yeah, it's not working, Sam. Smiley face, I like it. What does smiley face mean now in the words we're using? Min, I like it. We're getting there. And then that means?
Y is less greater than
Y.
dash must be 0. Greater than 0.
Y dash is increasing, decreasing. Y double dash is means a max. Y double dash now Minimum.
Less.
Opposite, remember? That's what's weird. You think it's less than, but in your head you gotta do the opposite.
Could you send it to me?
Yeah, come. It's document the number of come send it to everybody can send it. You can send it to yourself. You all there? Right on. Just go and find yourself and drag it up
Into your Skype chat. I might not be there. Go and find it there. All right. So pretty much for what values of x is this concave up? All right, here we go. Y dash. That's the hardest step, by the way. What you just did. Smiley, min, y double dash. Don't skip that step. Y dash equals 9 x squared minus 8x plus 5. Y double dash equals 18x minus 8. What must y double dash be? Greater than 0. Therefore, x must be greater than, can you see it? Plus 8 divided by 18. Can you see that happening? Or too fast? Too fast? Do it slower. 18x minus 8 greater than 0 plus the 8 divided by 18, which becomes 4 over 9 whatever. Center? Any questions? So as long as the curve is greater than 8 over 18, you always have something concave up. You'll have this bit being a minimum, whatever. Okay? Okay. Before we do curves, what's the time? 150. I think one more. HSC question, here we go. No, HSC, there it is. Let's do that one. See? You get to see the marks. 2 points for where it crosses the axes, so x and y intercepts, page 18. 4 marks for stat and nature, 1 mark for inflection, 3 marks for sketching. Find your x and y intercepts. So first you make x equals 0, you'll get y equals 0, and then do y equals 0, and you'll find your x intercepts. Maybe on Wednesday. Okay, well, can you get that again, hopefully? Probably some network issues, I hope. All right, let's start. Let me do it, finish it off. But hey, look, like I said, you guys are now in year 12, so literally whatever you learn is tested. So it's not like going to be like year 11, you learn a whole bunch of everything and then only 20% of year 11 is going to be tested in your HSC. Everything here, whatever you learn, is tested. Cool. So this, as you can see, I said 10 marks. It's actually exactly 10 marks. 4, 6, yeah, 10. Just how it is. So let's do it. Find the coordinates of the points where the curve crosses the axes. X is 0, you're going to get y equals 0. When y is 0, you'll get it looking like this. What do you do at this stage? Factorize x cubed. X minus 4 equals 0. Therefore, you get x equals 0 and x equals 4. You're done. That's your part I done.
Please, see you soon. Double I. Turn the key to the left.
Go. Stat points. Y dash equals 0. What does y dash equal to? I did say up here, try to draw y dash and y double dash. I didn't do it, I'm sorry. 4x, it just makes it a little bit easier to read. And then y double dash is 12x squared minus 24x. Okay. Y dash. Again, we have this thing. 4x cubed minus 12x squared equals 0. What do we factorize out? You guys are realizing the common theme happening with the question. What do we factorize out now? 4x squared. 4x squared. X minus 3. So x equals 0 and x equals 3. What do we do at this stage? Say it again. Find y. So back into the original. 0. So in 3 to the 4 minus 4 times 3 times, wait, 3 cubed. 20, negative 27. Agree? Done. That's 2 marks. You're done. Stationary points. Now you go to nature. So you can get 4 marks. Not bad, hey? Let's just not waste too much space. And let's do nature here. Nature, we write at 0, 0 and at 3 and negative 27. Okay. At 0, 0, what does y double dash equal to? Well, we know it's up here, right? 12x squared, blah, blah, blah. So just sub it in. What is it going to become when you sub in 0 into this? 0. And what does y double dash become when you sub in 3? 12, 3 squared minus 24, 3. 36. Okay, so what am I going to say with the second one? Greater than 0, which means it's a? This one up here, we can only say it's a possible POI, point of inflection. 4 marks. Triple A. Find the coordinates. See how it just says that? Find. And it's worth only 1 mark. So everyone's like, but it just said find, so I found it. No, prove it. If you don't prove it, you lose a mark. You don't get that mark. POI. Y double dash equals 0. So what was it? 12x squared take away 24. 12x squared take away 24x equals 0. Again, what do you factorize out? Correct. X equals 0 and x equals 2. Sub it in. Back into the original. 0. When you sub it in, you get 0. That could be a horizontal point of inflection now, right? Because we got 0, 0 at POI and we got 0, 0 at stationary points. True? So we'll come back to that in a second. 2. 2. Sub it into the original. Where is it? There. 2 to the power 4 minus 4 times 2 cubed. Negative 16. Done. What do we do at this stage? Y double dash table. Is that what you mean? Because remember, there's a few tables. You've got to be specific with me. Yes, we're going to do our Y double dash table. X, Y double dash. And for this guy. For every point you've got to do it. There's 2, there's 1, there's 3, there's 0. There's 0, there's 0, there's minus 1, there's 1. You could, eventually, when you're good. I think if you get comfortable with it yourself and you know what you're doing, yes. Someone like me probably can. And sometimes I don't, just because it confuses me. But if you get really good at it, yeah, why not? All right, y double dash, something -1. So 12 plus 24? I'm pretty sure. This should be 36. This one, 12 take away 24. -12. At 1, we already worked it out. It was just -12. At 3, 36. All right, what just happened? For both of them. There was a, what's the word you got to say? Change in, yeah, you got to say that. Since change in concavity, which means there's a change in it moving from a max to a minimum, concave. Yes, one's a point of inflection, the other one is a horizontal point of inflection. What did we say about horizontal points of inflections? They must also be, how do you know the difference between a point of inflection and a horizontal point of inflection? How do you know if something's horizontal point of inflection? It's got to be stationary as well. And how do we know it's stationary? Well, right there, you've written step point 0, 0. You got the same point 0, 0. So it's an inflection point, but it's not just an inflection point, it was also a stationary point. So it's stationary and it's an inflection. So it does that. Whereas this guy is just new. He's just a point of inflection. He's just this thing. So let's write that now. Since change in concavity 0, 0 is a horizontal point of inflection, and 2 and -16, 2 and -16 is a point of inflection. Good job. And I think the last bit was to sketch it. Sketching is not hard. IV. Yes, obviously it takes time. You know, it's meant to take about 3 hours divided by 180 divided by 100 marks, 1.8. So it's meant to take you technically 18 minutes. That's it. Yeah. Yeah, HSC exams 3 hours. So it's meant to take 100, you guys have to complete it within an hour and a half. So we're going to aim for 1.5 hours, max. We'll have to do the paper twice. Worst case scenario is 2 hours. Most of my talks are at an hour and a half. So yes, you'll be given 3 hours, but I think you only need about an hour and a half. Anyways, 1.8. So really, if you're looking at 10 minutes, I think you're looking good. And 10 minutes is a long time as well. You just got to get used to the math. For one question, for 10 marks. My recommendation, just do this question over and over again. This exact one. Time it. Time it your first time when you go home, tomorrow, whatever. Time it. Takes you 15. Try to divide it by 2, and then divide it by 2 again. Really try to push for that. Same question, don't change it. At least you know most of the math. Just get your hand used to writing fast. All right. 0 and 4 was an intercept. 0 and 4 was an intercept. At 0 and 3 was a stationary point. At 0, we realize it's a horizontal point of inflection, but at 3 and -27, at 3 and -27, this guy here, we realize it's a minimum. True? Just making sure. And then at 2 and -16, we realize it's a point of inflection. So that means it's not just doing this. It's not just going straight up. It's a point of inflection. It's got to change a little bit at that point. So this is happy, and then it's changing like that technically. Cool? Now watch me draw it. We start up here, horizontal. Ugh, started way too early. Oh, so hard to do on this. You can do it. No. All right, one more time. Okay, there we go. Can you see that's a little horizontal point of inflection there? Good. And then that guy, if there was nothing else attached to it, it would just look like this. And that's it, just scroll down. But because there's a point of inflection right there, it's starting to do that. Can you see that happening? So if I was to draw it, if I was to do the whole happy, sad thing for you, see, happy, 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 point of inflection, changed, sad, 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 and then what happened here? Happy, 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 happy again. So every point of inflection, it's got to change from a happy to a sad, or vice versa. Done. That's 3 marks. So this curve sketching wasn't hard for 3 marks compared to all the math you had to do for it. All right, let's talk about homework. Stop the